se lo vemos.
The same presentation that I'm giving here, I'm going to be giving on the App.js conference. That it's a pretty big and amazing React Native conference coming now in May, and it's going to be streaming on YouTube. This is a totally concised presentation. The one that I'm giving there is going to be bigger, and the reason because this one now it's smaller is because I actually just started studying and preparing it. So there are going to be more examples coming up on the conference. If you are interested, you can follow me on X and you can watch it the rest in 28th of May. And yeah, let's just continue with it. As I mentioned, we're going to go through a couple of basic user authentication terms. And with that in mind, there are a couple of terms that I'm going to speak, and I thought that was good to put those on the screen, give you a brief introduction and a quick summary without going too much into details. Identity federation, it's a term that we use for a server that it's usually responsible for persisting identities. And there are many examples of this nowadays. You could have Google Workspace, or you could have Okta. I think any OAuth server or OAuth provider could also be visualized as an identity federation. So for example, if you have a Meta account, there's a group of identities inside of Meta servers, like Meta accounts, that could be shared between multiple applications in the world when you're signing with Facebook or Meta. That's why it's considered a federation. And so this is an important term to keep in mind as we proceed with the rest of the examples. Single sign-on, it's also a term that has been getting really popular since 2010, pretty much, which is the ability to reuse a single set of credentials across multiple applications, or essentially reusing the same identity in multiple applications, but leading to the creation of specific application accounts. And a simple example of that is that you, for example, you're watching this, you have your employee account on Gmail, I presume. And then with that Gmail, you can pretty much sign into a lot of internal applications that you use on a daily basis without having to remember that single plain text password. Authentication factors, it's another term we are going to talk a lot, and I would say it's the main thing that I want to bring in for you to take out of this talk, which is the ability to build multiple layers of authentication and identity proof on top of another. So you could have password, and you can have email links or biometrics. You don't need to have only one. And in fact, the majority of the most secure applications nowadays, they use multiple factors of authentication. Then there is passwordless. Single sign-on, it's also sort of a similar type as passwordless, although you have a set of credentials that might include a password. Passwordless is the idea in which you can authenticate with something in which you don't necessarily need to remember or store plain somewhere and copy and paste it. And it's often something that you have, either like biometrics or something that comes from your device, like a secure token. And biometrics is just, I don't know how to explain this in English, to be honest, neither in Portuguese, the literal meaning of biometric, but it's often something that you are. So like Face ID or your fingerprint. So with those terms in mind, let's continue. So authentication itself is the act of validating user credentials based on something that the user knows, has, or is. And this is where the multiple factors come in. So often there's the first factor authentication, and there's the second factor authentication. And really, if you are integrating with any auth provider out there, I work at Clerk, but I'm not going to be biased. I'm going to give a lot of examples. You have Auth0, you have Stitch, etc. So if you are an engineer and you are integrating with an auth as a service provider, we often use a lot of those terms on our documentation on our API. So it's important to be familiar with that. The idea that the first factor of an authentication is actually super weak because it's something that the user knows, for example, a password, it can be easily leaked. Like someone looking at your password and that's just it. You are compromised, your account's compromised. And then there's a second factor that comes into place, which is a combination of multiple things. It's often something that the user has and something that the user is. Is usually biometrics, and has is usually more like device-specific things, such as secure tokens that are stored on your hardware. And we're going to be diving into it more details during this talk. And this is what I believe, and this is what I try to resemble regarding the future of authentication, not specifically to React Native, but the idea that along the years, applications, especially in the mobile landscape, because you can leverage the mobile hardware and not rely on browser only, are going to leverage more and more second factors, especially passkeys, which is a topic we're going to be looking at. So let's go a little bit again through every single one of those examples with actual strategies. So password strategy, it's one of the most common things, something that the user knows. Often the user might have a password vault, like 1Password or something, in which it's going to store this password, something that they know in the most secure way. Or at least this is what I hope everyone does in the end of the day, because password breaching, it's still a pretty common thing. Then we have TOTP, which stands for time-based one-time passcodes. And it's usually generated from a previously registered device. And it's considered something that the user has. And the reason for it is because on the user device, you would have an authenticator app. Those authenticator apps, they essentially implement the whole, how can I say this in English? Cryptography. I think you know what I was trying to say, although I don't know if I spelled it correctly. The whole crypto-like logic around public key and private key, implementing the whole auth specification against an auth server. This is usually not something, the communication between those authenticator apps in your application server, it's not going to be something usually that the engineer is going to build since the beginning. You can build in-house. There's any spec out there that you can go through. But if you are in a startup and you don't have enough resources, all of the auth providers out there, auth as a servers, they are going to expose APIs, endpoints, or components that are going to be able to integrate. The user can actually scan a QR code that is going to integrate with an authenticator app. And those codes, they are uniquely generated based on those crypto keys and on the current time. So it's super difficult for a man-in-the-middle attack or those things get intercepted because it's always generating a new one. And TOTP is often used as a second factor along, for example, email and password. You can use TOTP via an authenticator, which is the most secure way. But as a user, you might remember, for example, those codes being sent to your phone number or to your Gmail account. The reason that I don't think it's so secure, especially as phone numbers, it's because, at least in Brazil, last year, you cannot believe the amount of cases of like people getting their phone SIMs cloned. And when hackers get access to your phone number, they can, and you have a lot of those TOTP codes being sent to your phone number as a second factor, it's pretty bad. Like they can get access to your Instagram account and everything that you can imagine. So yeah, authenticator apps for the win. It's the best way in which you can deal with TOTP. So the third factor, something that the user is, often biometric information. And you can see in a lot of iOS applications, you will have the ability to scan your fingerprint or, for example, use Face ID. This is also often used as a step-up auth. I don't know if you ever heard the term of step-up auth, but you for sure have used it on a daily basis. So let's use the example of bank applications. Bank applications are the best examples when it comes to implementation of user authentication, because they have done it for years and years, have gone through the worst like security attacks possible. So those softwares, they actually learn a bunch. And what usually happens is that you have one set of password to sign in, but every time that you try to make connection inside of the app, it asks for another password or even biometric information for sensitive actions. So every time that you go make a transaction, it asks you for your Face ID, or not necessarily the Face ID from the hardware, from your native platform, but sometimes using like external services that scan your face and do some verification of identity based on your uploaded password or any other documents. And we call this step up off because on the authentication space, sessions, they also have levels of authenticity. So on the mobile app, when you authenticate with password, for example, your session is pretty weak. And let's say that at some point you want to introduce a feature which is super sensitive and it requires the user to really prove that they are who they are, like to complete the action. But let's say that that feature is specifically, it's only available for a specific amount of users. So you don't want to change the main auth form. Let's say you want to just keep password. That's fine. What you can actually do, it's a step up off technique, so that when the user clicks to use that feature and to complete the action, you trigger this authentication strategy, usually using biometrics, to be able to confirm and proceed with it. So that's really common. Clerk is actually implementing it, and I'm saying it because I think it's amazing the work that I'm not involved with, but that the other teams did about it. It's called re-verification. And everything is built in within components, on React components. It's beautiful. You don't need to code this from scratch. And the coolest thing about it is that you can look into this literally like a session object, and you can see the levels of authenticity on a JWT token. And I don't have it here on the screen, but definitely like something that I would recommend to go to Clerk Docs afterwards and take a look at it, or I can also put it on the chat. So as we talk about the feature, it's also important to go a little bit back in the past and remember everything that we went through on the mobile landscape as users. So as mobile technology has advanced along the years, so did the ways that attackers started to find out ways to get through those specs. And authentication mechanisms, of course, had to adapt. When we talk about the new authentication strategies, mechanisms is like the product of many engineers out there, sometimes in like groups in which it's totally not profitable, but they create those specs and organizations and even like academic papers introducing those new ways of authentication, leveraging the latest capabilities of hardware, and especially like literally this is the worst word in English. Cryptographically, I think, yeah, I'm not going to be able to talk, and I'm going to speak here wrong during the whole talk, but I hope you get it. Anyway, in the most secure way, along the years, new protocols have arisen. So let's just take a look at it. If you use it, one of the first iPhones or literally like mobile apps, even in the web landscape, right? The old and good password in 2007, 2010. The thing is that I remember back then a huge amount of password breaches attacks. It was like impressive. I remember there was like one incident of an 11 years old kid that had hacked PlayStation Live and grabbed like a bunch of user passwords and stuff. And so it was pretty insecure from the principles of not the password as a strategy itself, but that every single software house and software product, they had to rebuild these mechanisms of storing passwords and having to encrypt it in a secure way without to avoid data breaches. But it wasn't like based on a specification. Every single company done it in a different way. And along the years, things started to get actual specs and standards with protocols. So in 2011 and 2013, it was the first time where the world has ever saw a button with signing with Google, where it was the origin of OAuth and social logins. And this idea of single sign-on, as I mentioned, because if I already have a Google account or if I already have an Apple account, I just want to use this set of credentials in order to create accounts in other applications. And this was also something pretty important coming from enterprise companies, that you as an employee didn't have to remember that many passwords to get in so many internal softwares. You could just sign in with a single identity. And so I don't have it placed here, but there are other protocols that have arisen back then, which is SAML and OpenID Connect, which is essentially an extension of OAuth 2. So those protocols are super important, and I think in a lot of our engineering lives, we get to implement every single one of those. Hopefully, you don't have to build it from scratch, and you can use like an authorization server to abstract that out. So later, hardware started to improve, right? We are not using that pretty small phone anymore. We actually now have better capabilities, and then biometrics started coming to pictures, such as scanning fingerprint. Then in 2014, 2016, Touch ID, Face ID also became a thing. And now, 2014, 2016, we have passwords with passkeys that I'm going to explain in the next slides what it is. And what I say now, even though it's 2016, it's because passkeys is still quite a new thing. That's why I say it's the future, because if you're going to integrate this, even on web or mobile, it's not something really standardized. It's difficult to implement. Things are still moving in the community, and especially for React Native, the experience is not that good. I'm going to bring a couple of examples later, and we are going to take a look at together. But we have passkeys on our Expo SDK at Clerk behind an experimental flag, and I would love for, if you're watching this here, if you could give it a try afterwards and let us know if you have any feedback. But yeah, it's definitely something that is the future, but super important to learn as an engineer now, because I think it's going to replace a lot of the older strategies that we have been using in the latest years. So there's a difference between native auth experiences and browser-based experiences. And each of those, they have their trade-offs, in which I'm going to talk about. So browser-based experiences, it's often used for SSO flows. And sometimes it's not something really that you can avoid, right? If you have the requirement on your software, for example, to implement SAML, which is an authentication protocol that requires redirections between the browser and the application, you're going to have to implement a button in which, when user clicks on it, it's going to open the browser pop-up on the device. So when I say it's bad, not necessarily it's something that you can make the decision to avoid it, because it could be a requirement. And the thing is that it is a little bit of a context switching, right? So there's a lot of user friction when the user clicks on the button to sign in with GitHub. It goes to another application. That's normal. But another thing is that it also relies on browser settings, and we know that relying on cookies and browser APIs, making sure like to sync this with your development environment and how web cookies play with different domains is really painful to make it work. but sometimes it's required. And again, there are a lot of auth providers out there that abstract those flows so that as an engineer coding this in a React Native screen, you literally just have to go to the provider, create an application on the auth provider, and integrate with your UI using, for example, the React Native, or let's say Clerk Expo, React hooks, etc. Now, the thing that I like the most, which again is the future, is the native auth experiences. When we say native, it's when the user doesn't have to get out of that screen to authenticate and to prove who they are. So it's like seamlessly experiences, less context switching, flexible auth methods, and better session control. So you have passkeys as an example, TOTP as well. TOTP not necessarily could be used as a second factor, but it could also apply this as a first factor, for example, and you can have a native TOTP input in which the user could automatically autocomplete based on their authenticator app. And another thing that I think it's a must for every single native application that is created nowadays, it's offline authentication, in which if the user goes through a period of bad bandwidth, they are going to be able to open the app and the resources related to that authentication server is still going to be loaded. Because this is the worst thing ever, where your actual app logic already has some offline thing. I don't know, you may use some Watermelon database. I don't know if you ever heard of it, which is like no like functional databases on device, in which leverages the device secure store, async store. And so you can actually already offload a couple of your business entities. But if you're using an auth provider, then you must also make sure that those resources, they are being persisted, not only the auth tokens, but everything that is required to identify if it's a sign in or sign up, or if the user has a current session. So anyway, let's take a look into this. Let's start with passkeys. Passkeys, it's something that as an end user, you might have already started to see in a lot of applications that you're using on a daily basis, especially on the iOS landscape. So this is an example what it looks like in Android, but I want to give, of course, a full introduction of what passkeys are. So passkeys, it's a method of signing in into devices in which it leverages the hardware of the device to generate keys. It's like often composed of a public key and a private key. And then those keys, the public key, it's shared with an authentication server that is going to then store and be able to communicate with your device in an asymmetrical way. So I don't know if you ever heard, if you're familiar with asymmetrical crypto, in which you have a public key and a private key, and those can be used in conjunction to be able to encrypt information and decrypt information without being able to have an interceptor in the middle, because the private key is always stored on the device of the user and on encrypted storage. Those keys, they're also persisted on the cloud. So it really depends on the platform. If you're using iOS, this is often stored within the iCloud keychain, because with the reasoning that if you buy a new iPhone, you're going to be able to reuse those keys. And Android, I'm not familiar which cloud it goes. I think it's Android something, I forgot the other words. But it also has a cloud mechanism. And you also have passkeys in the browser, but then it leverages the browser engine, of course, depending on the platform that you're using, if you're using Safari or Chrome, etc. Right? So let's see if I forgot to explain something here. I have a couple of notes because, it's impossible to memorize everything. Yeah, I think that's pretty much it. Okay, so I'm actually going more in depth now on how passkeys work. And I've built this diagram. We also have, if you're curious, I might link to this in the chat afterwards, a documentation on Clerk Docs in which it has a lot of good diagrams on how passkeys work and how you can integrate passkeys with Clerk. And I took a lot of this flow from there. So huge kudos to the amazing Teams Docs at Clerk, because I think the flow that you're having there, although it looks pretty creepy, it's really straightforward. So let's start from point 1 here. So the user device is going to request a challenge from the server. And the server is going to send something back, which is called a challenge. It's like a totally unique and random characters, which is encrypted. And it goes to the authenticator, which is the number 2 that you can see there. Maybe I can use my mouse. The authenticator, when I say authenticator here, it's really the hardware, right? So you could use the browser API, or you could use the native hardware from the platform, iOS or Android. And the authenticator is going to check with the user that they are trying to sign in. You know, it's going to check like against, you know, the keychain or the device. Another thing that I forgot to say, maybe it's a little bit too late now, but I don't know if you ever used something called YubiKey, which is something you can plug into your computer, and on that YubiKey you can store passkeys. So this is super useful to maintain like sessions, especially from enterprise identity federations or like your employee account. And it's also a form of device that can store those keys. But anyway, continue. So we are on point 2. Then 3, the authenticator, it's going to check with the user that they are trying to sign in, which I think I already mentioned that, right? Yeah, anyway. So 4, on confirmation, the authenticator signs the challenge using the private key that I mentioned before, which is only the device that has access to, and then it sends to the server. So the 4 point here, it's really the best benefit of using passkeys and why it's so much secure, because your device has access to it. Only if someone stole your phone, then they're going to be able to use that. But in any means, from the network perspective, it's impossible to hijack that. So on 5, the server is going to validate the signature against the public key that you have stored at first. And if it's valid, the server is going to complete the request and create a session, right? So it's usually those 5 steps, and it's combined by the device, of course, the user playing into it and making the actions, server, which is going to be your auth provider. In this case, could be Auth0, Clerk, etc., or your in-house server that implements the passkey spec, which is actually not called passkey spec, it's called web authn. So those are the main components. Let's see if I have anything other to say. Yeah, that's mostly it. So let's continue. So now I'm going to go through code snippet examples. And before getting into it, I first want to apologize because I was actually supposed to bring an actual mobile application running this. But while I was making the example, I recognized that Clerk passkeys is not working pretty well with Expo development builds. And the Clerk passkey package is still an experimental flag, so I'm going to look into it totally after this presentation. And I'm going to try to fix it, and then I can follow along with your team and I can forward a GitHub repo with an actual example. But by looking at the code snippets, hopefully you can have a better idea from the interface perspective on how this can be integrated on your React Native app. And again, I'm going to be taking in consideration that we're using Expo here, not a bare React Native app. And you're using Clerk as a provider, but the mainstreams providers out there of providers, they must already have implemented at least like a beta feature on their servers to be able to create passkeys, right? So often on your application, to integrate with passkeys, you're going to have a couple of components. You need to have a component which is going to create the passkey, and it's going to interact with the hardware, the calls behind the scenes. So at Clerk Expo, we have a React hook, which is called use user. And from this hook, you can get actually the data of the user that is currently authenticated. But not only that, there's a method in which you can create a passkey for that user, right? And so it's really just a method call, and the Expo behind the scenes, it's going to make it agnostic per platform. So you don't have to handle every single case on Android or on iOS. It's just like, multi-platform, and that's it. So that's the API that we want to provide. Simple as that. The next thing, it's an actual button in which it says sign in with passkey. And then this code snippet has a couple of things. I'm just going to quickly go into it. One thing that you may notice is that on the last line, there's a return button, and it's HTML. And this is something that I noticed afterwards, that it's an issue on our docs, and I copied from there. So we need to fix it because on React Native, you actually should use either the button component from React Native or a touchable from the platform. My apologies for that. But in the end, it's going to be like a touchable button, and it's going to be on press instead of on click. So on the off provider side of things, at Clerk, we have a couple of entities, and one of them is called signing. Signing is an object in which it exposes ways of authentication and the status of your current signing flow. So it's simple as a React hook, and it's going to return that object from our API. On this object, there's a method in which you can authenticate with passkey. And behind the scenes, the SDK is going to send to our servers and do the whole like hardware and private key handling, right? The only thing that you as a developer have to care is to make sure to do the actual Clerk specific API checks, which is like verifying if the signing attempt is complete. And when I mean by complete, it's because of that last thing that we saw, which is multiple authentication factors. Often on a Clerk application, we have multiple settings available for the developer to choose if they want password only, password passkey, or password and email links. So the status might return as actually missing requirements, and then you have to progressively render the form on the mobile screen according to the next requirements, right? And a little bit of error handling in there, but you can take a look also at the Clerk docs if you're interested about it. All right, so now in terms of biometrics, this is a super simple screenshot that I found from the Android simulator with fingerprint sensor. This is an API that behind the scene Expo can trigger and can pop up, again, regardless the platform. And I'm sorry, it's too much of code, but I'm going to go through each of a single line. So usually, like, you cannot use fingerprint or Face ID as a way of auth itself, right? It's a second factor, or use it for step-up auth, as we talked about. So you're going to have a signing form component, and then you're going to have like something rendered in which is going to do a progressive signing with like Face ID or Touch ID. And second option, which is what I'm showing here, is when the user already has signed in for the first time with the main Office strategy, which could be, for example, off. And then for the next times that they proceed to sign in, they can actually use Face ID or Touch ID, because the main thing is that they have already provisioned their accounts, already know your name, already know your photo, everything. But then just to show who you are, you can keep up signing in with biometrics. So this is also a way, and it's the way that we recommend on our docs. Again, you don't have to deal with any native API. This is just a matter of calling a React hook, and I think it's the best developer experience that you can have. So this is an Expo page. There are two Clerk Expo hooks here. It's like use sign in and use local credentials. So then we have a little bit of React state for the signing form, but this is totally redacted. I should have removed it because it's blowing up this snippet here. And then we have the handler. So before creating the sign-in, we actually verify if you already have credentials set. And if you can use local biometrics, this is based on the device permissions. And if you do, if you have already signed in, because you can see on this line, after only the first complete attempt that we set the credentials, then it's going to authenticate. And authenticate comes directly from the library. This is a handler behind the scenes in which, based on the preferred biometric type of the device settings and permissions, it's going to pop up on the platform the ability to do the signing with Face ID or Touch ID. And then there's like some conditional here to conditionally render the button afterwards, depending on the data that the React hook has mounted with. So that's it. And another thing, it's offline support. At Clerk and at Expo, it's as simple as one property. And in reality, it's just like, it's a pretty simple thing to do. And I see that a lot of applications, they just forget about it. It's leveraging the secure store of your phone. And what we do at Clerk is that all of those resources that come from our API, because we use the stateful authentication. So everything, it's a ATP call, like to fetch if the session is active or if it's sending a sign up. We actually cache those things on your storage, also taking in consideration storage limits and etc. And we do this in conjunction with Expo Secure Store, which is an Expo library you can use for many other purposes, but we store our resources there. And then if you're building an Expo app with Clerk, if you're familiar with React, you have your tree and you have your layout. You often have a context provider for many libraries, for example, HTTP clients, let's say React Query, you have your React Query provider. We also have a Clerk provider, which is that whole thing that I saw to make the React hooks work with the context about the user signing in, etc. So on that provider, you actually pass a property, which is called experimental resource cache. And as simple as it is, you enable offline support on your app. It's still experimental because there's still a couple of less things that we have to cover, but it's something that we have on our roadmap to finish, and it's the ideal experience that we believe that apps should have, React Native apps in general. And yeah, I think it was it's a pretty short presentation. As I mentioned, I wanted to bring an actual working application, but I didn't manage to because I struggle to make the package work behind the scenes with passkeys. And so I just want to say, like, if you have any questions about Auth in general to bring, I'm here, and I could spend a lot of minutes just like teaching about any other type of stuff that you're interested in the Auth landscape. Hopefully this was useful somehow to bring the idea, at least of the requirements and the things that your app should support from an authentication perspective and security perspective. And yeah, if you don't have any questions now, just let me know on social media and send me a DM on Twitter. Thank you so much.
Hi. Thank you, Laura, for sharing your time and knowledge. And we have a few minutes if anyone has any questions. And we have Laura.
Pueden hacer las preguntas en español también. Voy, yo voy a entender, pero
En portugués.
en portugués, es portugués
En
en español.
portuñol.
Portuñol.
Ahí, Elias.
So, Laura, what would you say is you have a lot of competitors, like here in Reservamos, we used for a while Out Zero and also Stitch. So what do you think is like the main advantage of using Clerk instead of those platforms?
I love this question. Yeah, so Clerk is mainly UI focused, I would say. Like, we treat authentication as components based as much as possible, as Lego blocks. Uh, and so, for example, especially if you're building a web application with React, in comparison with our competitors like Auth0, you don't need to build the whole UI from scratch. We actually have components that can do this whole interaction, and yeah, it's just like better from a front-end engineering perspective. And furthermore, we perform a whole user management solution. So it's not only about authentication, it's everything that is around a user object. So I don't know if you followed, but we have released billing, which is essentially, if you're building a B2B SaaS, you can integrate with Clerk, and Clerk's not only going to handle authentication, but it's also going to handle building and authorization, etc. Something that Auth0 still doesn't have and Stitch doesn't have as well. I would say that if I was going to put this in one phrase, Clerk is a developer tooling with that one of the goals is to allow developers to build B2B SaaS as the most fast paced as possible. So you don't have to build everything that a B2B SaaS needs in terms of authentication, billing, and authorization from scratch. Hope that makes sense.
Sure. Yeah. And how do you think the support for passkeys is gonna evolve? Like right now, I think a lot of people don't know about this, and you said it's mostly experimental with Clerk, but when do you see this more like this future happening?
Yeah, this is a really good question. To be honest, I don't know quite precisely to answer. But you see, let's take a look at actual dates. Like passkeys, as the spec itself, it was first introduced to the community in 2016. And right now we are in a point where the majority of the platforms, they already support it, and the main cloud chains, you can also persist it. And I think it's already pretty well covered, but the majority of the majority of the issues, I think, is developer experience friction on like how to integrate this between many platforms, because it's pretty inconsistent. The way that you integrate passkeys in the browser, it's a totally different way. On native, it's a totally different way. And to be totally fair, for React Native, the experience is bad. And that's one of the reasons that I want to take a look at Clerk passkeys again, our package, and improve it. Because if you're building directly into the native layer, I think iOS and Android, they are already doing an amazing job into exposing the actual interfaces to the hardware. But for React Native, we still haven't got fully there. I think for multi-platform frameworks in general, and that might be one of the reasons why a lot of auth providers like out there, they haven't really shifted abstractions for passkeys with native just yet, although I see a huge support for browser, so yeah, maybe asking your question in a more precise way, I think the mobile industry needs to level up a little bit more in terms of integration, because it's still not as a standard. And from the browser perspective, we are almost there. So that's what I believe, essentially.
I think also it's not as easy to understand. Like,
Yeah.
I think that may be something that is taken into account. Like, you need like a diagram to really understand why is it secure.
Yeah. I think the first auth methods that I usually learn as an engineer, it's password or auth. It's pretty straightforward in way of like redirects and access tokens, but now passkeys and biometrics is bringing more like this interaction with the hardware itself. It's a different way to visualize things, and during this presentation, I also explained it in a way, if you're using an auth provider like auth as a server, but imagine that you have your own in-house auth server, then it makes things even more difficult because you need to implement the whole server logic to accept those keys and handle it, which is not trivial. Like, it takes time and effort. So yeah, I hope that along the years we could change this spec of passkeys and make it easier in some way, or at least like as auth providers we could make our best to give like good documentation for developers on how to integrate those.
Dale, Bruno.
Hola, muito obrigado por la plática. So my question is, are you trying to implement also other methods to identify the user? I saw that you are implementing biometrics and like serverless and single sign-on. But for example, I have a friend who just had his Netflix account stalled, no? So if you see in the logs that there was a login in Indonesia, like, of course, it's obvious that it's not it's not this person, right? So it's not my friend who's living in Mexico, who's paying in Mexico. So I don't know why that part is not integrated in a whole system on login, like in Mexico right now, it's to log in into your bank account, they ask you your position, geographic position. So that's kind of like, like it's invading your privacy somehow, but at the same time, it's also not like preventing stealing your account, like hackers in Russia using your account to send funds to the other place. No, so I don't know if you're trying to implement something like that also.
Yeah. Well, I hope that your friend somehow gets the Netflix account back. But yeah, so I don't remember, like, I use Netflix. To be honest, I don't quite remember how many office strategies they use. I know for sure email and password and auth. And I think if I remember correctly, email code, but I don't quite remember if they use some sort of like identity proof on native applications. So this could, in a way, like this is something that avoids an attacker to log in behalf of your friend because they wouldn't bypass Face ID, for example. But yeah, another thing that I would say it's regarding fraud detection. It's a topic that it's not related to authentication itself. Somehow it's like an extension of the product of user authentication that Netflix has, because it sent an email to your friend saying that someone from Indonesia accessed the account. So usually, Clerk is actually implementing this as a server, as a service. So usually what happens is that when you detect that a session is created in another IP, we either block the sign-in or we proceed with communication of like sending the email and allowing the account owner to reset the password, right? And this is what we call fraud detection, which is often something that if you're building off in-house, you don't have, because it's complicated, it's not trivial. There's a whole thing of like how to detect if it's actual real usage, or if it's a bot, or if it's really like a malicious actor. And so at least Netflix does this pretty well. I imagine that your friend might have been able to reset from there. So yeah, that's what I have in mind to answer your question. We do have, as I mentioned, the authentication protocols to prove who you are, but sometimes not all applications, they do that. And when it comes to then your account gets leaked, if you at least have this fraud mechanism to recover it, it's good enough. Not the best case scenario, but good to have.
Ok, muito obrigado.
De nada.
Genial. Pues para cerrar vamos a hacer una fotito, ahí si les parece. Si pueden prender sus camaritas, ahí Bea nos va a ayudar con tomando la foto, porque aquí yo en el stream tengo un cero bien raro.
Sí, yo ayudo aquí. Nada más vayan prendiendo sus cámaras, porfa. Y yo tomo la foto.
Dame chance de peino.
Listo, voy a tomarla. Todos sonrían. Ay, denme un segundo.
No se ve de la bici.
Listo, ahí voy, ahí voy. 1, 2, 3. Listo, equipo.
Súper. Pues gracias, Laura, por el tiempo otra vez. Y nos vemos la próxima. Gracias a todos.
Gracias.
Bueno.
Bye.
Muchas
Thank
gracias,
you very
Laura.
much.